If you compare this problem with the previous one, which we have here, you can see that the only difference is this sign. There is a minus, okay, there's a minus sign here, and up there is the plus sign. So everything that we've done here can be repeated. The only difference is that here we're going to have a minus sign. So here there is a minus sign. So we have the same equation, this one, right? But with a minus instead of a plus there. So we have this 1 minus 2z minus z squared times f equal to, and on the right hand side we have something identical. We have this, all right? Z squared, we have this 1 minus z squared over 1 minus 2z. 1 minus z squared over 1 minus 2z. Okay? Right, so we can put this in the denominator, and then we have our expression for f. 1 minus z squared over 1 minus 2z. Okay? There is a big difference though, because in the previous case, having here a plus sign, we had this factor identical to this one, so they cancel, and we just had an ordinary geometric series, and the solution was very simple, 2 to the n, right? However, in this case, these two factors are different, and the expression that we have is more complicated, and we have to deal with it in a completely different way. So, well, let's see what we can do here. The first thing we need to do when we have something of this sort is to figure out what are the factors, elementary factors of the denominator, right? In order to make elementary fraction expansions. So let's see, and for that we have to find the zeros or the roots of this polynomial, okay? Which are this, z is equal to minus 2 plus minus the square root of 4, this is 2 squared, minus 4 times 1 times negative 1, so plus 4, over 2, okay? Which is minus 2 plus minus square root 8 over 2. But square root 8 is 2 square root 2, right? Because 8 is factorized as 4 times 2, and the square root 4 is 2, and the square root 2 is square root 2, right? So you have minus 2 plus minus 2 square root 2 over 2. So this is a minus 1 plus or minus the square root 2. These are the two roots of the denominator, okay, of this factor here. So now we have to see how to write this factor, right? 1 minus 2z minus z squared gets factorized as this. There is a minus in front of the z squared, so there is a global minus. Then you have z minus the first of these roots, which is plus 1 minus the square root 2, okay? And there is a second factor, which is z minus the second one, which is plus 1 plus the square root 2. So these are the two factors, okay? Right. However, we don't want them to be written like this, because these are of the form, let's say, z minus a or a minus a, and we would prefer having something of this sort, okay? Because this is the nice expression that we need in order to have something like, well, the sort of series that, or expansions that we normally deal with in this kind of problems, right? So what we're going to do is to factor out these two numbers. Okay, so if we do that, what we have is, we take this as minus 1 minus square root 2 times 1 plus the square root 2. Okay, we get this factor and this factor, right? And then we have, here we have 1 plus z over 1 minus the square root 2. And here we have 1 plus z over 1 plus the square root 2. All right? So these are the two factors that we have. we have to deal with this, right? So what is this? Well, actually, this minus means that we can write this as square root 2 minus 1 times square root 2 plus 1, which makes sense because the square root 2 is larger than 1, so this number is positive. So actually, here, better than that, we should have minus here and these 2 times in reverse, like here. This is what we're going to do now, right? But before that, well, let me just change it here, right? So we have minus square root 2 minus 1. It's the same thing, okay? And just changing the sign here and here at the same time, right? Okay, so we're going to see what this is now. This is the difference times the sum, so it's the difference of a square. The square of the square root 2 is 2, the square of 1 is 1, so this is just 1. So we don't have this factor here, there's only a 1. And not only that, 1 over square root 2 minus 1, which is the factor that we have here, you put this here, is equal to square root 2 plus 1, right? Because the product of these two is 1. Okay, and similarly, 1 over square root 2 plus 1, which is the factor we have here, is square root 2 minus 1. So this complicated expression becomes simply 1 minus square root 2 plus 1 times z, okay, after this replacement, and 1 plus square root 2 minus 1 z after doing this replacement here. So that is the factorization that we are going to use for that. So the function f finally has this form. Is 1 minus z squared divided by 1 minus 2z, that's the first factor, the second factor, and the third factor are these two. So it's 1 minus square root 2 plus 1 z, 1 plus square root 2 minus 1 z. There you go. And now, as usual, we have to expand this in elementary fractions, one fraction for each of the factors, because all the factors have multiplicity 1 and they have different roots. So one is this, the other one is this, 1 minus square root 2 plus 1 times z. Okay, and this one is c over 1 plus square root 2 plus 1 times z. And as usual, what we have to do is to multiply by the denominator here and get a polynomial expansion. So we have 1 minus z squared is equal to a times the product of this and this. But remember, the product of this and this, right? These are the two factors in which we are factorizing this. So this here is just this product. So this product here, the product of this and this, can be written like this. I'm going to use this expression because it's going to be handier. So it's 1 minus 2z minus z squared. All right, this is what we have over there, the product of these two factors here. Then we have b, which is 1 minus 2z times this one, so 1 plus square root 2 plus 1 times z. And then we have c, which is 1 minus 2z and 1 minus square root 2 plus 1 times z, like this. All right, and now we have to solve for a, b, and c. Okay, the typical thing to do now is to substitute by particular values and obtain the values here. One obvious value that we have to substitute is z equal to 1/2, because if we do this, then this cancels out and we only have this term here. 1 minus 1/2 is 1/2, so this is 1/4, this term here. This is equal to a times 1 minus 1, right? 2z is equal to 1, minus 1/4, right? 1 minus 1 is 0. Okay, so what we have is minus a divided by 4, and from this we infer that a is equal to 1. Okay, so that's the first factor, the first value that we need. Then we could try to substitute here, but this is going to be complicated because of the multiplicity of factors here. So we're going to do something more clever right now. What we're going to do is to substitute this value and simplify this expression. Let's see. You have here this binomial. So this is 1 minus 2z plus z squared, expanding the binomial. Then in this side we have minus this factor, which we can put in this side here as plus this factor, which is 1 minus 2z minus z squared, right? And that is equal to these two terms, which contain the common factor 1 minus 2z. So we can write this as 1 minus 2z times b times 1 plus square root 2 plus 1z plus c times 1 minus square root 2 plus 1. There is a plus that should be a minus here somewhere. Yes, this is a minus, the one that is with c, okay? So this is a minus. Minus 1 times z, okay? So there is a minus here, okay? So minus 1 times z, right? Okay, so there is a minus here. Square root 2 minus 1 times z, okay? And here we have plus 1 times z, right? So this is what we have now. Look, these two terms disappear, and we have twice 1 minus 2z here. That is equal to 1 minus 2z times this factor here. So this cancels with that, and then we end up with a simpler expression to deal with, which is this: b times 1 plus square root 2 minus 1 times z plus c times 1 minus square root 2 plus 1 times z. Okay? All right. Now we can do this. We can take z equal to square root 2 minus 1, for instance. Okay? If we do this and we put it here, we have square root 2 plus 1 times square root 2 minus 1, and that is 1. 1 minus 1 is 0, so this goes away. So I have 2 equal to b times 1 plus square root 2 minus 1 squared. And if I expand this, what I have is b times 1 plus the square of this is 2. The double product is 2 square root 2, and then I have 1. Or b times 4 minus 2 square root 2. Right? Okay, I can factor out from this. I can factor out 2 square root 2, this down here, and then I have 4 divided by 2 square root 2 is just 2 over square root 2, and this is just square root 2. So I have square root 2 minus 1 here. Okay? And of course b. Right? So this must be 2, the 2 cancels, right? So b is equal to 1 over square root 2 square root 2 minus 1. And remember, 1 over this factor is equal to square root 2 plus 1 over square root 2. This is the form that we're going to use, all right? All right. Now, let's take the other factor, which is going to be minus, let me see. Yeah, minus square root 2 plus 1. The reason is, when we introduce this here, this times this is 1, with a minus is minus 1, 1 minus 1 is 0, and this term goes away. So I will have 2 equal to c times 1 minus, and then, plus, and then the square of this, square root 2 plus 1 square. And if I expand this, I have exactly the same as this here. You see, these two terms are the same except for the sign. So I'm going to have c times, well, I can use this form, right? 2 square root 2 square root 2 plus 1. That's the form, that's the answer I'm going to find, right? And after simplifying and doing the same thing, right, what I'm going to have is c equal to 1 over square root 2. Square root 2 plus 1, and 1 divided by this is square root 2 minus 1 over square root 2. And this is the form we're going to use, right? Okay, let me recap, right? So function f is equal to 1 over square root 2 multiplies two factors, right? The first contains b, and it's this one here, okay? And b contains this factor. So I have a square root 2 plus 1 over 1 minus the square root 2 plus 1 times z, right? Okay, look at this, right? And then I have this one, okay? And this one is plus square root 2 minus 1, all right? This one here, the square root 2 here is here, and then divided by 1 plus square root 2 minus 1 times z. Okay, and finally, remember a is equal to minus 1, so this last fraction, minus 1 over 1 minus 2z. Let me rewrite this this fraction, this function in a slightly different way. The reason is I have this fraction here, okay, that's okay, this factor. Then I have this fraction, square root 2 plus 1 over 1 minus the square root 2 plus 1z. This already has the form of a geometric series, right? This one, okay, 1 minus w, this is w. But this one doesn't, because there is a plus here. But there's an easy way to change this plus by a minus. We can just reverse these two terms and put a minus, okay? So if we do that, what we have is, here is 1 minus square root 2 times z, okay? And if I put the same factor here, 1 minus square root 2, then I have to put a minus here instead of a plus, right? And then I have 1 over 1 minus 2z. Okay, then this way I have the two terms here have this form, and we can use the geometric series for them, right? So that's this one. And not only that, the factor that you have here, up and down, is exactly the same. And this is going to be easier to just gather in a single expression. So let me just erase this and continue. So now what we have to do is to expand this. So we have 1 over square root 2. This series here is, of course, square root 2 plus 1, or let me write it in a different order, 1 plus square root 2. Okay, just to have it like in this order here. And then the sum from 0 to infinity, 1 plus the square root 2 to the n, set to the n. This is this first term. Then we have minus 1 over square root 2. Then we have this factor, 1 minus square root 2. And then we have the sum from 0 to infinity of 1 minus square root 2 to the n, set to the n, right? And finally we have this, which is minus the sum from 0 to infinity, 2 to the n, set to the n. All right? Okay. This factor is equal to this factor is equal to this. So I can write this in this way. The sum from 0 to infinity, and then I have 1 over square root 2, which is a common factor of this to the power m plus 1, because I'm multiplying this by that, right? Then minus this 1 minus square root 2 to the power m plus 1, again, because I have this and this, okay? Everything gets multiplied by 1 over square root 2, and then I have minus 2 to the n, and everything is multiplied by z to the n. So finally, the expression I find for the coefficients of the recurrence, well, for the sequence of the recurrence is equal to this. It's 1 over square root 2, well, or better, 1 plus the square root 2 to the n plus 1, minus 1 minus the square root 2 to the n plus 1, divided by square root 2 minus 2 to the n. Okay, that is the final answer to our problem.